Alright, we get that going. Let's start by recapping what we've covered in the category so far. So, first thing I want to bring to mind is the way that Aristotle uses this word predicated and this word in. So we started out with this square, right? And in the square we talked about something could be in or something could not be in. Something could be predicated or something could not be predicated. So he starts out with this way of categorizing a bunch of simple concepts. Now give me examples of each. Let's start with the easiest, not in and not predicated. What were these?
Predicators.
Yes, your primary substances, your particular things. I don't exist in anything, I am a particular thing. Furthermore, you can't predicate me of anything else. I'm the only me that there is. I'm this individual particular thing. Same with that chair, same with this piece of chalk. So these are individual particular things. All right, then we have predicated but not in.
Human.
Human, man. These are your secondary substances. These are collections of primary substances is one way you can think about it. They're universals whose instances are these things. Man is here, chair is here. Is red here? No, because you can't talk about particular red. You have to say a particular red what? It has to be in something. I talk about a particular man, it doesn't have to be in something. I can't talk about a particular red. I can't talk about a particular running. A particular running what? Has to be in something. So things that can be predicated but also have to be in. This is where you have like red or running. Here's most of your adjectives. And then probably the weirdest one, in but not predicated. What were those?
Memory.
Things like your particular memory of something. So not the universal memory, as in has a memory, but your particular memory of our last class. Your particular understanding of the Pythagorean theorem. The Pythagorean theorem itself, that's a universal. Your particular understanding of the Pythagorean theorem now, that's something that only exists in you and can't be predicated of anyone else. It's special to you, it's unique to you, and it exists in you. But it's not the same as you. So, memories are a good example of things down here.
Would like body parts be an example of in like an eyeball or something?
So when you talk about your right eyeball, then we're talking about an individual primary substance, an individual particular thing. When we're talking about eyes, being eyed somehow, it depends on how we're using it now. Being a sighted thing would be right here. Eyes, as in we're talking about eyeballs, would be right here.
So sight is in predicate, and then what I'm seeing is a not predicate in.
Well, what you're seeing is whatever you're seeing. If you're seeing that particular chair is here. I mean, everything you see is going to be in this category.
True. I'm just wondering, do things that are in and not predicated, can they be a substance, or are they more?
These are going to be subjective.
Okay.
Meaning only you can have any experience of those things in you.
So like if I'm
Your toothache is a good example here.
so okay, and then like if I'm feeling wetness,
So that direct experience of that wetness, that's somehow in you. But being wet is something that we can predicate with multiple things.
interesting.
So remember that we're not necessarily talking about words, we're instead talking about simple concepts. Because sometimes you can use the same word to refer to 6 different concepts. And then some simple concepts we might have to put a bunch of words to. For example, we say in room 5, that's a simple concept. I could also say here, that makes sense when I happen to be standing here, you know I mean in room 5. But if I were somewhere else, that word no longer works. So talking about simple concepts, not necessarily words. And so when you try and pick one word, it depends on how you mean the word.
You mentioned running inside of in and predicate. What would it be in and not predicate?
Huh?
Running. What would it be in the context of a particular?
I'm not understanding you. So running is here. That's something that you can see me doing. And I can be running at one point and I can stop running at another point. And running is no longer predicated on me. So the other way that we talk about these is these are essential properties, these are accidental properties.
I think the mistake that I'm making is I'm looking at predicates as the forms, and that's not the case.
So when we're talking about the forms of objects, as in by how we classify them, those are all in this category.
I see. Interesting.
Okay, so that's one thing that we talked about last time. The other thing we talked about last time is his theory of definition. A definition, you state an object's genus and its differentiating specification, which gives you a species. And so we start out with some particular object like you, and we say you are a man. And we say men are, you can put mammals there, or you can skip straight to animals, doesn't matter. Or you can put more categories in between man and animals. And you might say animals are living things. And you keep going, and the question was, could you go back forever? Or is there some initial category that you have to start with? And we said, Aristotle says that there's some initial category. And in this case, it's going to come back to substance. And if instead we were talking about a 5 foot or something like that, then it would have come back to the category quantity. And if we were talking about red, you know, red is a color, if we work all the way back, then that would come under a quality. So his 10 categories are our 10 initial genuses from which we define everything else. Remember, his categories ultimately, big picture, what is Aristotle's categories? It's telling us how we use words and what words mean. And then on interpretation, it's going to tell us what we mean by certain sentences. And then when we get to prior analytics, what we typically call logic, it's how we can combine sentences together to form valid arguments. So first we need the words to build the sentences, then we need the sentences to build the arguments. And that's the flow here. So this first one, we're still focused on words, defining words, classifying words. What do these words mean? That's what we're doing here. Okay, and then so here's that one direct taste of Aristotle, because he gives you the 10 categories in his own words all in one go. So a thing said without any combination. So we're talking about simple things, simple concepts. A thing said without any combination. Each signifies either substance, or quantity, or qualification, or quality, or a relative, or where, or when, or being in a position. That's how an object's oriented relative to itself. Or having, or doing, or being affected. Doing and being affected, those go hand in hand. Doing is what you do, being affected is what's done to you. So,
what's relative?
Huh?
What's relative?
Relative means it takes 2 terms. So we'll give an example of each really quick, and then we'll do a deeper dive into each. So to give it a rough idea, examples of substance are man, horse. Examples of quantity are 4 foot, 5 foot. Of qualification or quality are white or grammatical. Of a relative, double or half. Notice that it takes 2 terms. You would say x is double y, or x is half of y. Or larger, x is larger than y. Needs 2 terms, that's what he means by the relative. Of where, in the Lyceum or in the marketplace. Of when, yesterday or last year. Of being in a position, is lying, is sitting. Of having, has shoes on, has armor on. Of doing, cutting or burning. Of being affected, being cut or being burned. So those are his 10 categories. None of the above, it says just by itself in any affirmation. An affirmation is a statement that we can call true or false. So you can't call any of these things by themselves true or false. But the things that we want to call true or false, our sentences, are going to be composed of these things. So, none of the above is said just by itself in any affirmation, but by the combination of these with one another, an affirmation is produced. For every affirmation, it seems, is either true or false. But of things said without any combination, none is either true or false.
So all sentences are affirmations?
No. But all affirmations can be encoded in sentences. So he would say. Okay, so that's his own language giving you the 10 categories all in one go. We'll do a deeper dive into each of these 10 categories to make sure that they all make sense. So the first and most important of these categories is substance. Substance is subdivided into 2 things, primary and secondary substances. Primary substances, that's this square. Secondary substances, that's this square. So this one category is going to talk about these 2 squares. And the other 10 categories, or the other 9 categories, talk about these things. So, primary substances, that's these. Individual, particular entities. Secondary substances is those. So, primary substance, that which cannot be predicated of anything or be said to be in anything. That's what Aristotle will call it. Hopefully now that makes sense. Primary substances. Can't be said of anything and can't be in anything. Secondary substances, those that can be predicated of something, but still cannot be in anything. Man, animal, but not wine. So that's this category. Or this section of the square. Together, these make one of his 10 categories. So far, so good? Those two definitions for what he's talking about make sense? All right. So the things that aren't primary substances. So if we're not a primary substance, what are we? So things that aren't primary substances are either predicated of primary substances as subjects, or are in them as subjects. What do we mean there? So here's primary substance. Let's look at things that aren't primary substances. First off, let's talk about secondary substances. What are secondary substances? They're the things that we can predicate of primary substances. Right? So, things that aren't primary substances are either predicated of the primary substances as subjects, or they are in them as subjects. In other words, pick something over here. Running, what's running? It has to be in something. You have to predicate it of some primary substance in order for running to exist. Similarly, pick something over here. Your memory of last week's class. That has to be in you. Otherwise, it doesn't exist. So his point is that all three of these other parts of the square are dependent upon this part for their existence. So these individual substances are in some sense primary in that everything else is dependent upon them for their existence. In other words, Plato, it's not the forms exist by themselves, and then we happen to resemble the forms. If the forms exist, they exist here in particular things. It's particular individual things that are primary. So you might feel like he's put a lot of emphasis on that, but remember, he's coming right after Plato. So if the primary substances did not exist, it would be impossible for any other things to exist. So, not in, not predicated. This is just me re-explaining the square, so hopefully this makes sense now. Not in, not predicated, those are primary substances. Not in and predicated, those are secondary substances, which are just groups of primary substances. So when we are talking about things in, and either predicated or not predicated, but most importantly in, they have to be in something, i.e. a primary substance. That all makes sense? So primary substances are primary in terms of if you put like some order of existence.
I still didn't quite get a clear picture on, okay, so when we have a in predicate, is there always an instance of that in the not predicate in not predicate?
You're saying down here.
There's always an instance of the, is there always a instance of a in predicate in the not predicate in? In not predicate.
Let me try this one more time. Here's the analogy that worked with you last time. These are classes.
Yes.
These are instance of classes.
Yes.
These are types of properties. These are the actual values a particular instance has for that property.
Well, like for instance, you mentioned that wetness existed in predicate, right?
So wetness could be here, as in you're saying something is wet. You're predicating wetness of something.
Yeah, like
your experience of wetness, that actual sensation, is subjective. Only you have it.
And it's an instance of that category of experience, right?
Yes. You could talk about being able to experience wetness as a concept up here, and then the actual experience of wetness down here, your actual particular experience of wetness down here.
So that is my question really, is that for every in predicate, is there an experience instance of that in the in not predicate?
There might be.
Like an experience of running.
Here's a better way to think about them.
Okay.
These are the ones that I can see you have. These are the ones I cannot see you have. I can see if you're wet. I cannot see your experience of wetness. I can see if you're painted red. I can see if you're running. I can't see or experience in any way your memory of last week. So these are completely subjective. Only you can experience these. These are not subjective.
So there isn't really. There isn't a one-to-one relationship.
Yeah, I wouldn't think about it that way.
Okay.
I think about objective properties, subjective properties, individual particular things, groups of individual particular things.
Objective properties, subjective properties. That makes sense.
Okay. I think we did this all, right? Okay, so next. So, a couple things he notices about substances to help you figure out you got some particular concept, where do you place it? So if it's a substance, here's what's going to be the case. First off, substances don't admit of degrees. In other words, all men are equally man. You can't say that's more man, that's less man. Remember, going back to Plato, he says, by accumulating the virtues, you better resemble the man in this form. And then if you lose that virtue, now you less resemble the man in this form. Aristotle says, no. If you're a man, you're a man. If you fit the definition, you fit the definition. And if you don't, you don't. And there isn't more or less in this sense. You can be more courageous than another person, but now we're talking about a quality that that person has. We're not talking about the person as such, the person as a person. So they don't admit of degrees. Second off, they don't admit of contraries. What's the opposite of me? Doesn't make sense. What's the opposite of black? White. What's the opposite of tall? So those have contraries. What's contrary of me? What's contrary of man? What's contrary of bird? They don't admit of contraries. And then it's the special, it's distinctive of substances. It is distinctive of substances that what is numerically one and the same is able to receive contraries. So individual particular objects are capable of receiving contraries or exhibiting contraries. In other words, it is possible for me to be at one point in time white, and then me, still being the same type of thing that I am, at another point being black. It is possible for me to eat a bunch of food and be heavy, and then lose all that weight and be light. It's possible for me to be strong and to be weak, to be healthy and to be sick. It's only substances that can admit of these contraries. It's not possible for running to be walking. It can't admit of its own contrary. So it's only substances that can admit of contraries and still be the same thing that they are, the same substance. All right, so that's it for substances. Any question on those before we go to the next category? Quantity. All right, so next we talk about quantity. Quantity, again, is subdivided into two, the continuous and the discrete quantities. Continuous quantities, these are lengths of lines, areas, volumes, intervals of time, distances, etc. Now, there's a bit of confusion amongst philosophers what he's talking about with continuous quantities, because he talks about surfaces and bodies rather than talking about areas and volumes. And this is a consequence of them just not being familiar with the mathematics at the time and not going through something like Euclid's Elements. In Euclid's Elements, he would say that this is equal to this. And when he says that they're equal, he means that they have the same area. And it was just understood convention of the day. And he wasn't saying that they're not actually identical to each other. I don't know, you said you were going through the work. I don't know if you've gotten to that point yet. But he'll talk about two triangles being equal to each other, and if it's your first time through it, you'll probably get confused and say, those aren't even close to equal to each other. What are you talking about? Saying they have the same areas. That's what they mean. When they're talking about two surfaces being equal, it's just what they mean by they have the same areas. And when they talk about two solids being equal, it's what they mean by volume. So there's nothing weird about that to a Greek. It's just convention they adopted. They didn't mean that this is identical with this. So that's what he means by surfaces and bodies. Nothing confusing about it. And then there's discrete quantities, which he calls numbers. Now remember, for the Greeks, that numbers are rational numbers. Numbers and rational numbers are one and the same thing. That's what they mean. What's a rational number? It's something that can be expressed as a fraction of integers. So 1/3 for them is a number. and anything you can express in a similar way is a number. So why do they have this separation? This goes back, we talked about it a little bit with Pythagoras, but it's worth talking about again. If I construct a square, so at this length of the square is whatever our unit of measure is, 1 foot, and so that is 1 foot. And if we look at this dimension right here, across the center, what's the length of that line? It's the square root of 2 feet. Now the square root of 2 is irrational. So they prove that you cannot find two integers a and b such that a over b is equal to the square root of 2. There are no two integers that satisfy that. You can talk about 141 over 100. Okay, that approximates the square root of 2. And you can keep getting better and better approximations using more and more decimal places. But provably, there are no two integers that make this true, which is very disturbing. Let me give you intuitively what that means. Imagine you want to measure both this side and this side perfectly. So you see, you call this 1 foot, and you say, okay, how many feet is this? 1, and some leftover. So I won't use a foot. I'll use 1/100 of a foot. And so you'll break this side up into 100 equal pieces, and you'll say, okay, this is 100 of my new units. And if you start counting this out, you're going to be left with a little extra. You're like, shoot, let me try again. I'm going to break this up into trillions of pieces. And so I break this up into a trillion little pieces, and using that new little tiny unit, I perfectly measure this, and I still get a little bit extra. And no matter how small I break this up, there is no small enough unit I can use that it perfectly goes into this. That's what that means. These two lengths are incommensurable. Very disturbing for the Greeks. They didn't know how to talk about this length as a number. What is it? How many units is it? It can't be expressed. So there's some quantities that you just can't assign a number to. And this is why the Greeks went crazy developing everything with geometry. You know, people when they first see how Euclid's doing his geometry and then they see algebra later, they wonder, why did he do it with all this geometry and never with the algebra? And it's because geometry seems to be able to talk about quantities that algebra can't. With arithmetic, you can only talk about numbers. But geometry, I can talk about this length. I can talk about that quantity. It's not a number. Of course it is. We call it square root 2 now. But they said it's not a number, but we can still somehow talk about it. So it's somehow different. Anyways, so that's what they mean by continuous quantities and discrete quantities. Continuous quantities are what you can construct with geometric figures. Discrete quantities are numbers. So the two examples Aristotle gives as discrete quantities are the actual numbers, and then he goes on to say, and speech. He thinks about speech as being distinct syllables. Yeah, syllable, syllable, syllable. And they're not continuously connected, but there's space between each one. This is why he uses continuous and discrete. He thinks about each number, there's space between it. If you were to take your real number line and plot all the rational numbers, Aristotle would say, and there's space between any two of those. They're in some sense not continuous. There would be holes.
Wow. Can you find an infinite amount of rationals between every rational?
We'll cover this in real analysis. Yes, the rationals are dense in the reals.
And he didn't know that? Or he didn't think that?
He understood that, but he also understood, I think he understood that, but he also understood that there'd be holes in some sense.
How?
Because the square root of 2 isn't on here, so there's a hole there. And there's infinitely more irrationals than there are rationals.
Yeah.
So for every one rational, there's infinitely many irrationals. Give you another sense of it. The rationals have the same cardinality as the integers. There's exactly the same amount of rationals as integers. So there's a way of writing them out so that they're all separated. You just run them through that mapping.
Yeah, right.
You can't do that with the reals. They're continuous. They'll always still be connected like that.
Oh, that makes sense.
Anyways, so that's the difference between discrete and continuous quantities. Now, quantities alone are related by being equal and unequal, with the unequal always being greater than or less than. So if we're talking about two quantities, either they're equal, and if they're unequal, you can always say that one quantity is greater than or less than the other. And this is a particular property that quantities have. You might say, what about colors? I could say that red is not equal to blue. Sorry. Red is not equal to blue. But Aristotle would say, okay, but then what are you saying? Are you saying red is greater than blue, or is blue greater than red? Which way does it go? And then you realize that breaks down. So that's what he's saying here. Quantities alone are related by being equal and unequal, with the unequal being greater than or less than. That only happens with quantities. Anything else you can do that with, if you can do that, you're in some sense referencing a quantity, directly or indirectly. I might ask, are these two rocks equal? You would say no. You say this one's greater than this one. Well, indirectly you were referencing their mass or their size or something like that. So anytime you indirectly do that, you're indirectly referencing a quantity. So ultimately, if we were to be very careful in our speech, it would always come back to a quantity if we can think about it this way. That make sense? Strictly speaking, we cannot say two colors are equal to two types, or two types of sweetness are equal without reference to some quantity. Gave you the examples of color, but another example would be sweetness. Are these two sweets the same? No? Okay, then which one's greater, which one's less than? Okay. Quantities also do not admit of contraries. What's the contrary of 6?
Negative.
Now, half of you might have said -6, and half of you might have said 1/6. And then those of you doing it -6, you're thinking about that in terms of 0 being your identity element. Then you'll notice that 0 is its own contrary, which is very weird. What's the opposite of 0? 0. We don't like that.
Bizarre number.
If you would have gone with 1/6, then you would have known that 1 now is its own contrary. What's the contrary of 1? 1. Something is its own opposite, we don't like that. Doesn't make sense. So quantities too do not admit of contraries. Any argument you can make for -1/6 or -6, I can make for 1/6 and vice versa. And you're going to run into these weird scenarios that you realize, yeah, I don't really like that. All right, anything else with quantity? All right, relatives. Relatives or relations, that's typically what we call them now in modern language, relations. Strictly speaking, what's a relation? It's a two-term predicate. You give it two terms and it spits out true or false. So that's what we mean by relative or relation. States how one object is related to another. Predicates that require two terms to make sense of. Have to give it two in order for it to make sense. Example, double. The only way double makes sense is if you say x is double y. You have to give me two terms in order for me to say, yep, that's true, or nope, that's false. Similarly, greater than. X is greater than y. Now, Aristotle talks about proper relatives. Proper relatives are the relatives that always have a co-relative. If x is double y, then y is half of x. Double and half are co-relatives. They're the contraries of each other. You're going to notice that proper relatives always admit of a contrary. That's a proper relative. One that always admits of a contrary. And if x is greater than y, then y is less than x. Less than is a co-relative of greater than. Since relative terms are not absolute, there is no contradiction in a term being greater in one sense and lesser in another sense. In other words, my height is greater than Bob's, but less than Jack's. And there's nothing contradictory about that. Again, you say obvious. This is one of the things that Plato would use in his arguments over and over again. One of the reasons Plato thought that we could have opinion of best of this world. I think one example he gives is, you lose a tooth in your mouth. You fill that space with your tongue and it feels massive. You fill it with your finger and it feels small. It's both massive and small. Your senses are telling you it's large and it's small. Contradiction. Or you talk about some object and you say it's great relative to this thing and it's less relative to this thing. Or it's small relative to this other thing. So it's both great and small. But things can't be both great and small. And so our senses are confusing us about this world. Because there's all these contradictions in this world. So we can have opinion at best of this world. And all knowledge is really about the world of forms. Where there's absolute greatness and absolute lessness. Whatever those mean.
Saying Socrates still believed in this world of forms.
Did I say Socrates? I meant Plato.
Oh, that's
Sorry. So Socrates comes before Plato. Plato is the one who builds the concept of the world of forms. Aristotle's coming after that.
That's what I'm going to say. Aristotle, did he also use the world of forms in his philosophy?
No, we just gave huge arguments against it.
Okay, okay, so you're talking about Plato was saying that.
Yes, Plato. So he's coming after Plato. I'm saying, why is he putting so much emphasis on this?
Yeah.
It's because Plato was doing this left and right to show you, not just Plato, but in particular Plato, was saying the reason that we can't have knowledge of this world is this world keeps emitting of contradictions. In one sense, that hole in my mouth is large, in another sense, it's small. In one sense, I'm large, in another sense, I'm small. I'm both large and small. Contradiction. I can't be both large and small. And if you allow for contradictions, you can't have knowledge. And so we can't have knowledge about this world. We can only have opinions. And our senses are always lying to us, telling us it's large and telling us it's small. And our poor soul getting all this sensory information is so confused. That's Plato. Aristotle says, no, no, no. Those are relative terms. There's no contradiction. So that's why he explicitly makes note of that. Don't get sucked into these arguments that my teacher is making. Example. We may say that there are few people in the theater and many people in the house. When I say that there's few people in the theater, what do I mean?
It's not very full.
It's not very full relative to how full it normally is. I can say there's few people in the theater when there's 100 people in the theater, and say there's a lot of people in the house when there's 10 people in the house. And when we say that, we mean that usually the house has less than 10 people, and usually the theater has more than 100 people. And so you can't use these to construct contradictions. Right? I can't say since there's few people in the theater and many people in the house, there's more people in the house than in the theater. No, they're relative terms. And they mean it relative to something else that they're not making explicit. So, we may say that there are few people in the theater and many people in the house, and yet there may be more people in the theater than in the house. It's not a contradiction. Any questions on relatives and correlatives? All right. Next one, quality or qualification. I typically call them qualities. Qualification or quality. This is a property possessed by an object. For example, white, black, sweet, bitter, hot, cold, brave, foolish. Qualities do admit of degrees and contraries. What's the contrary of white? What's the contrary of courageous? Uncourageous. So they do admit of degrees and they do admit of contraries. Being swift is going to be a quality here. We might say you're fast and we might say you're fast. But we can still say, and he's faster than you. So it also admits of degrees, and there's a notion of being faster and less fast, stronger and less strong, more courageous and less courageous. So contraries make sense when we're talking about qualities, and degrees often make sense when we're talking about qualities. Now, not every quality has a contrary, it's just that they can. So if you were to ask Aristotle, what's the contrary of yellow now, he might say, I'm not sure. And that might depend on how you lay it out on a color spectrum and then go find the other thing over. So it doesn't have to admit of a contrary, but they can admit contraries. Okay. And he splits up our qualities into 4 different subcategories. So there are 4 common types of qualities. He doesn't claim that these are the only ways you can split them up, but he finds these useful ways to split them up. So first type of qualities he talks about are habits or dispositions. So these are all the virtues that a person may have, and all their vices fall into this category. So being wise, being temperate, being just, being courageous, those would all be habits or dispositions that you have. He would call those ones habits. Dispositions are short-term, habits are long-term, is how he splits them up. And then also, if you were foolish, if you were intemperate, if you were unjust, or if you were cowardly, those would also all be habits or dispositions. Next one he talks about are inborn capacities or incapacities. The one he does over and over again is a man is a natural boxer. We talk about someone is a natural athlete. It's some inborn capacity that they have. It doesn't matter how much I train, I'm never going to be as good at basketball as LeBron James. He has some innate capacity that I do not have. Now, he's taller and stronger, but so that gives him an advantage there. But you can still look at two people, you know, they got the same build, they're kind of the same size, and yet one's just that natural athlete. There's something intrinsic in him that just makes him really good at this thing that you can't really get at. So, inborn capacities. Being quicker than another person, being healthy. You know, some people, just by disposition, they happen to be healthier people, hard for them to get sick. Other people, you see them getting sick all the time. Being clever, that's an inborn capacity or disposition, something you're just born with. Your natural talents, etc. IQ is what people would most likely put in this category. And then your affection qualities. These are qualities that other people can somehow, it creates an affection in other people. So, for example, hotness. If something's hot, that creates an affection in you. If something's sweet and you taste it, you can taste the sweetness. If something's bitter and you taste it, you can taste the bitterness. So sweetness, bitterness, he puts in these categories. Hot and cold, he puts in these categories. Color, he puts in this category.
What does he mean by affection?
It creates some effect in someone that's not the object. So we say this object is hot. How do we get that? Because of the affection it creates in you when you touch it. We say this object is sweet. How do we say that? Because of the side effect it produces in you when you taste it. It has some affection. It creates some effect. And then finally, the figure or shape of a thing. Whether it's round, curved, straight, square, large, small, whatever.
That's quality?
Yeah, that would be a quality that something has. That is a very round stone, a very spherical stone.
And the degree would be how close it is to the shape that it...
Yeah, how spherical it is. Oh, that's kind of spherical. Oh, wow, that's a perfect sphere.
Gotcha.
Good? So that's what we have for qualities. Now, place and then time, these are both quick ones. So place is where or place. This is your position in relation to your surrounding environment. Example, in the Lyceum or in the marketplace. It says where you are relative to your surrounding environment. Similarly, when or time is your position in relation to the course of events. Example, yesterday, last year, this morning. What about 1 hour? Is that time? No. Aristotle would say, no, that's a quantity. A time is when I could meet you. So if I say, Parley, let's meet 1 hour, what do I mean?
1 hour from now?
Right, so I have to say it relative to some course of events. Imagine that you are setting up a dinner date for an alien species that you have a walkie-talkie to. And you say, I want you to come meet me at this time. What time are you going to tell them to come meet you? You're going to schedule it for some thousands of years in the future. How do you tell them when?
That's irrelevant.
I don't know, you'd have to coordinate a time schedule.
Right. You say 1,000 years. Well, what do you mean by a year? And 1,000 years from when? Or imagine that you got some ancient note from history and you want to know when it was. And they said, we're in the year 2300. 2300 from what?
Always relative. Could be relative to now or another time.
Right, so all our times, when we're talking about time, we're always talking about time relative to some other agreed upon instant of time. We count all of our years from the birth of Jesus. That's what our calendars count from. If I talk about yesterday, that's in reference to today. Or if I say 2 hours from now, that's 2 hours from now.
So intervals are not considered...
Intervals of time are quantities.
Okay.
5 hours is a quantity. 5 hours from now is a time.
Gotcha.
Similarly, this one's a bit more obvious, but 3 meters is a quantity. 3 meters to the right from me is a position. All your positions and all your times are relative. you notice that you run into the same problem. I give you a walkie-talkie to some alien species, and you have to tell them where you are in the universe. You say, I'm in room 5. Great, where's room 5? Well, you give it the latitude, longitude, and altitude. That's where it is relative to the center of the Earth. Great, where is Earth? Oh, well, we're the 3rd planet from the sun. Okay, what's the sun? Ah, it's this star in the Milky Way galaxy. Okay, what's the Milky Way galaxy?
Yeah.
Have to have some agreed position that you both know that you can start talking about your position relative to.
Did he just differentiate between distance and like vectors, for instance? And you said, for instance, 3 meters right to you is a vector because you're describing not only a distance, but you're also describing a direction. And I was just wondering if he ever talked about that differentiation.
No.
Okay.
And, well, we won't go on that tangent, but I hate that that's how they tell people vectors. But that's what I get for being a math degree. No, that's exactly what they tell you. What is a vector? Oh, it's a magnitude with a direction. It's not a vector. A vector is a member of a vector space. It's something that satisfies the axioms of a vector space.
Well,
I like saying, what's a real number? It's something you can get to show up on your ruler.
I hope you get to teach that to me one day.
Well, if we do linear algebra, that's one that always comes
I'm
up.
extremely excited about doing linear algebra.
It's a pretty simple axiomatic system, vector spaces.
They are, and I took a
I think
class
it's a
on
simpler one than talking about real analysis, doing the axioms on the real numbers. Even though you have more experience with that one, those axioms are more complex, and the things you prove with them are more complex than just vector spaces. At least I think so. Anyways, so where and when, these are relative terms. They are your position in relation to your surrounding environment, or your position in relation to some course of events. And you have to have some agreed upon position or some agreed upon event to make it make sense what you're talking about. Whereas lengths of these things, lengths of time or lengths of place, are quantities, however you do that. Okay, I think I made that make sense. Any questions about place or time? And why they're relative? Okay. And then the last 4. He doesn't give much of an explanation of because he thinks they're pretty self-evident. So, being in a position. This is how an object's parts are positioned relative to the object. In other words, if I tell you where an object is, that doesn't tell you everything you can know about that object. You can also know how it's oriented. So if I tell you I'm in room 5, well, am I standing? Am I sitting? Am I laying down? There's still more information to be extracted other than just my position relative to my surrounding environment. There's how the rest of me is positioned relative to me. How the object itself is positioned relative to that object. So, being in a position, how an object's parts are positioned relative to the object itself. You might not know where I am, but that does not tell you where the parts of me are relative to my position. And then having. Here he comes back at the very end of the categories and gives more explanation of, but if you're interested. This is being in possession of. Example, I have knowledge of geometry, I have shoes on, I have a wife. He says, here's the softest way that we use it, and here's the strictest way that we use it. But those tend to be the ways that we use the word having. Doing or affecting, these produce a change in some other object, possibly but not necessarily changing the agent as well. Example, burning, I might go start a fire out in the forest. It may be the case that fire comes back and burns me. So I burn something, it may or may not come back and burn me, that's accidental. What we're talking about, the affecting, the doing, is the burning I created in the forest. Or if I burn you, get your hand really hot, and then your hand in turn happens to touch me, I in some sense burned myself, but that was accidental. So this is what you do to other objects. And then being affected, this is suffering a change from some other object, possibly but not necessarily initiated by yourself. Being cut, being burned.
So if I cut myself, I'm both doing and being affected.
Yeah, but you could kind of split that up into 2 separate actions. It's if doing one somehow caused a change to come back around and affect you.
But if I'm
simultaneously.
But it's the same, like, movement. If it's the same motion.
It would be kind of like you cut a piece of wood, and as the wood slipped, it cut you.
But what if I actually just cut myself?
So if you cut yourself, oh, then yes, both these are happening too. Okay.
Okay.
You are cutting yourself, you are affecting yourself. Yes.
And you're being affected by yourself.
Yes. Okay. Yep. Okay. And that's it for his 10 categories. Any questions on any of the 10 categories so far? All right, so no. Since the categories are the highest level of genera, they are not species as well. Remember, species and genera are relative terms. You take some genera, you find some differentiating specification to take some subset of that genera, and that gives you a species. When we were doing you, man, mammal, animal, we might say, what's a mammal? It's all the animals that give birth to live young. That was defining a species using animal as your genus.
What? Genera, genus? I didn't.
Oh, same thing.
Oh, okay.
Genera being the plural for genus.
Oh. Cool.
The highest level of genuses.
That's where general came from, right?
Yes. So going back to its earliest uses, when something was generally true, it was true of the genus. When something was specifically true, it was true of the species. That's where they initially come from. So since definitions define a species, this means that the categories cannot be defined. There is no definition for substance, strictly speaking. There is no definition for quantity, strictly speaking. So we have to rely on intuition. We have to rely on getting you accustomed with a bunch of particular instances and being able to abstract what all those have in common.
So it's similar to like an axiom?
Kind of. So this isn't the way that we currently do it. We currently use axioms and undefined terms, and we say that the undefined terms, or that the axioms give meaning to the undefined terms. So that it's more like acting like the undefined terms. But rather than those being what the axioms encode, these are instead, it's like a completely opposite view from what we use now.
I see kind of reverse here.
But only kind of. Because, no, in high-level fields, meaning not super rigorous like real analysis, we still use Aristotelian-type definitions. If you go take some class in chemistry, for example, they may not define what reaction is. But then they'll tell you endothermal reaction is one that doesn't produce heat, or something like that. And then if they did define reaction, they would give some Aristotelian definition in terms of reaction. They say it's, I don't know how they say it, it's something that changes bonds between atoms. And you say, okay, what's atoms? And they'll eventually get to some point where your teacher just says, we're not going to define that.
Yeah.
And so even though, strictly speaking, we produce axiomatic systems, when we're being lazy in these higher level fields, we still use this Aristotelian approach. When you go take some course, they'll always just go higher and higher to some term that they say, we're not going to define that.
Is that kind of, that sounds very similar to like an axiomatic system?
No.
How's it different?
So axioms, so if we were doing a Euclidean geometry course, one of our axioms would be every line contains at least 2 points. Point is an undefined term, line is an undefined term. Points and lines are terms that show up in our axioms. Another axiom would be, how exactly does it say? 2 lines contain at most 1 point in common.
Yeah.
And so that's a relation between points and lines. And axioms are expressing relationships between your terms that you're not going to define. Or I think it's every line contains at least 2 points. Any 2 points define a unique line. I think those are the 2 axioms.
What's the word for line and point in this context?
So in this context, we don't have it.
No, that context.
Instead, it's working up to the highest level. Rather than starting with points and lines, they instead go to the highest genus is, if you were taking some less rigorous course, they would instead say a point, they might try and define it as, you know, some piece of a line, and then a line is some part of a two-dimensional shape, and a two-dimensional shape is some plane figure, and keep going out further and further to something less and less particular. So it doesn't start with these very particular things, and then we build more broad definitions from. It's instead, the broadest things we kind of ignore, and we get more and more particular as we define things.
So, the way you defined it seems like the most accurate when you're just saying, if we were to supposedly try to define what a category is we look at all of the species and look at all the properties and then take all the common factors, common properties, and say, this is these properties.
Right, so he says, how do you come to know these initial categories? You can abstract to them. I can say, look, here's an example, here's an example, here's an example. Abstract what they have in common, and that's what we're talking about. And that's what we're relying upon for you to understand what a quantity is. If you're to try and define quantity, Aristotle would say, you're essentially just going to give me a synonym for quantity. You're going to say, something that you use numbers to represent. Number is a quantity? Yeah. Okay, we're back where we started. What's a quantity?
But you could look at all organisms have the cells, but an organism being high category,
But that's not one of his initial categories. One of his initial categories is substance, trying to find substance.
everything that exists in the universe, it was
Everything that is a physical thing, as in has some substance,
as a time and place.
you're going to have to
space.
come back to somehow talking about its physicality in terms of it's a substance.
Yep. Interesting.
Because already, you know, time and place, an event could fall in that category, which you wouldn't call a substance.
An event could occur in time and space.
Yeah, your memory of last week's class was that specific time and place. But regardless, so we have these 10 initial categories. These things don't have definitions. How do we come to understand them? Intuition. You somehow are able to abstract from a bunch of instances, and that's what we're talking about. Now, why can't we use being or everything as our first genus and then define these with respect to those? Aristotle says it doesn't work. For Aristotle, every genus must be differentiated by some differentia that falls outside the genus. So you have to differentiate it by differentiating it against some things that it's opposed to, that fall outside of that. Otherwise, it's not a genus.
You have to find something else.
Right. They're not being defined in terms of some subset inclusive things. They're being understood by excluding other things. This and not that. This and not that.
So a genus and a species can't be the same thing, basically.
A genus and a species can be the same thing.
In different contexts.
Mammal,
In the same context.
in the same context. They're relative terms.
Gotcha.
So for a particular species, there's a particular genus.
So,
But if you try to do this, then you say, what's a quantity? It's everything that's and you're left to say a quantity, and you're stuck.
Gotcha. That makes a lot of sense.
Okay, so just as we have genera, which cannot be species, the categories, the top 10 categories, those are genera that cannot be species. They can't be defined. So substance is a genera that is not a species. It's a genus that's not a species. Sorry, I'm going back and forth between genera and genus here. So just as we have genera which cannot be species, like the categories, so too we have species that cannot be genera. Species that are not further differentiated. These lowest species are only further specified by individual instances, or you break them up by these types of properties. These lowest species are how we typically use the word species today in biological taxonomy. So what we call species today are species that it doesn't make sense to then use as a genera for defining a new species.
Why can't we go down further?
For Aristotle, it gets to the point where so every species gets at that thing's essence. the things that are essentially the same. Look, if you go down forever and ever, you eventually get back to particular entities, which aren't species. There's no definition for you. You're a particular thing. So that's intuitively why there's some lower limit. Has to be some lower limit, because these are going to be collections of these types of things. So that's one piece of it. But he would go further, and he says that madness, for example, is a final species and is not something that you can further specify. There's no way to break this down more. He says any other property that you try to break this down by, you're going to be essentially using these types of things to try and do it. Accidental things. And things that are no longer essential. Essentially, what makes man man, he says, it's their ability to reason. Whatever we use for species today, like you're able to reproduce and chromosome count or whatever it is, can't break it down any further. And any further subdivision, you're now doing it by these things. You can subdivide us into the fast people and the slow people, the tall people and the small people.
What about something more concrete like gender?
Gender, that is also one that I wondered about. I'm not sure exactly how he would work with gender in this, because that seems like it gets at your essence.
It does seem like he would.
But I think he's okay with every species having the male and the female in the species. So that's not something distinctly human, because femaleness is something that you see in animals. And so it's not some differentiating specification for her versus him.
Where are the boxes? Like,
I still don't see it as a property though.
where are the boxes?
No, it's a property, male and female, it's a property, and it's also one of those essential properties. I can't take away your manness, now meaning it in the gender sense. I can't take away her womanness. That's somehow essential. Can't be removed.
Therefore, likely species, if we were to speculate on this deeper than he has.
So it is something essential, but it's not a differentiating characteristic as in, look, if you're going to now subdivide mammals into new categories, those new categories need to be things that those categories have that other categories don't have. Male and female is something that applies to animal as a whole. And so you can't subdivide humans into male and females and have them be separate species, because that's something that's predicated all the way back up here of animal.
Right.
It's going to have to be something unique to humans that you don't find anywhere else.
It's a weird restriction.
So when we subdivide, going back to animals, and we subdivide animals, two definitions we have is mammal and bird. I can't use, so I got mammal here, and I got bird here. I can't then further subdivide this into birds that are male and birds that are female, because that's not something unique to birds. This was unique to this in the sense that these lay eggs and these don't. And so it had to be some unique specification that didn't apply to everything up the chain.
Well, so he's basically saying that these categories have to be somewhat two-dimensional, because for you to break it up by male and female, you have to then go three-dimensional in a sense.
Well, no, it's just that differentiating specification has to already be unique to your genus that you're talking about. So I now have my genus, which is man. And now if I'm going to subdivide it more, I need to find an essential characteristic unique to man, so no other thing that we've subdivided has it. I need to find something unique to man that only these things have and these things don't. Like when we were splitting animals up into mammals and birds, we might have done it by gives birth to live young, lays eggs. Those have to be unique to animals for that to make sense. If plants also laid eggs, this no longer works. Or if plants also gave birth to live young, this no longer works. It needs to get at that essential characteristic that further subdivides that group and doesn't apply to groups higher up the chain.
I just can get so messy because we got frogs that lay eggs, we got fish laying eggs, we got.
Well, okay, so
mammals.
we don't really divide birds and mammals by laying eggs.
We
You're
apparently
right.
have mammals that lay eggs.
We do talk about mammals as giving birth to live young because they're the only ones that do it. And then the other ones lay eggs. So that was a bad example for birds.
What about the damn
Birds would be
platypus?
feathers. The platypus would be an exception.
So
At the
it's
time
just-
that he's given this definition, though,
okay,
he didn't know what a platypus was.
I don't know when I need to bring these up, but I just feel like he started a really great concept, but it just seems like it was too simple, and that there needed to be a way to.
He would not have said that his system is complete.
Yeah, I'm just saying, I don't know, I feel like sometimes we're defending him, and I'm just curious if that, we can just acknowledge that there's more to categorizing than this two-dimensional.
Well, we still use these systems today.
Yeah.
When you are in a simple high school chemistry course, all your definitions are going to be Aristotelian definitions. You're going to start with some genus that you may as well call a category for the sake of that course. And then from there, you're going to define everything. And that's how you're going to do it. So his system of definition is still largely used today. And it's only when we're being really rigorous that we say, okay, here's all the problems, we got to throw it out, and we got to be very precise. And we did that in our logic course. Our last logic was theory of definition, and what exactly that means now.
Okay, so,
We rarely need that much precision, but when we do, the
okay.
Aristotle system, no, it doesn't work.
Alright, I'll let it rest then.
Okay. Did we talk about all these? I think so.
Yes.
Okay. So now remember, his categories ultimately, he's talking about the way we use these simple concepts, the way we use these words. So those are his 10 categories, but it goes on because he's going to start talking about the way we use some different words that have come up a lot in philosophy and have confused a lot of arguments. One of those words is the word opposite. So Aristotle or Plato would use this all the time. Is this thing just? No, then it must be unjust. Or is this thing unjust? No, then it must be just. I doubt you would remember it, but one of his arguments for how justice, temperance, courage, and wisdom are all really the same thing is using this type of opposite argument. Is it unjust to be courageous? No. So it's just to be courageous? Yes. So the courageous is the just, and the just is the courageous. So it was how he used that word opposite. So Aristotle is going to break down how this word opposite keeps showing up. And when he's going to use the word opposite, he's going to tell you which of these opposites he means, and exactly what he means by it. So one of the ways that we use opposites is to talk about relatives and their co-relatives. Double and half, greater and lesser. Relatives and co-relatives. That's one of the ways that we use opposites. Pretty straightforward so far? Okay, next one. We use opposites to talk about the contrary. What's the opposite of all swans are white? No swans are white. What's the contrary of good? Bad. Note that while contrary of good is always a bad, the contrary of a bad isn't necessarily a good. Here's another way that Plato kept cheating. Now you might say, what are you talking about there? What's the contrary of eating way too little food?
Eating too much.
Eating way too much food. Is it good to eat way too little food? No. Is it good to eat way too much food? No. So the contrary of an evil isn't necessarily an evil, or isn't necessarily a good. On the other hand, what's the contrary of being courageous? Cowardly. So the contrary of a good, whatever word you choose, you're always going to pick an evil. But when you talk about the contrary of an evil, you're not always going to pick a good. And it's because the goods come in two sorts. We often talk about a good as in between two extremes, or we talk about a good in a binary sense as in good-bad. What's the opposite of committing adultery? Not committing adultery. Good-bad.
Yeah.
Where over here, you would say courage is in between being a complete coward, afraid of everything, and then being foolhardy and running into any danger without thinking. That's not courageous, that's stupid. Right? So he says, our goods exist either in between two extremes or there's this binary. But it's not always this binary. So that's what he means there. Plato treats them all as though they're like this.
Could it be a binary, or that you can never be too much in one area, too much in one direction? Let me think of an example.
So you might be thinking of something like wise and foolish.
It's like some people think that, well, it's good to be bad and good. I'm like, well, you're not really defining what People say that. And my point is you're not defining, like there's a balance between, good is a balance between good and bad, which is stupid and contradictory.
So there's Aristotle's golden mean in relation to habits of character. He says every good habit of character exists between two extremes which are both evil. So courage, for example. He would say liberality. You're not prodigal, wasting any money that you get, but you're also not a miser, hoarding all the wealth you get. And he says, pick any good habit of character that you want, and it will exist like this, between two extremes.
So you could, interesting. So you could even say like integrity or honesty could be too much.
Right. There's a difference between being honest and saying any little thing that occurs to you.
Yeah. Interesting. And then integrity could be that you said you do something, but you realize it's going to cause a disaster, but you do it anyways because you said you would or whatever.
Right. Integrity, sticking to your word when it counts. In some sense, you don't go and do everything you ever said you would just because you said you would.
Especially if you realize that you don't not produce the result you expect.
Or you're joking or whatever.
Or you agree. Yeah. Interesting.
All right. So, contraries and quick side note because, yeah, Plato does a lot of that in his arguments. Aristotle doesn't like it. Another way that we use this word opposite is in terms of privation and possession. What's the opposite of being blind? Having sight, being sighted. Those are in some sense opposite. So blindness and sight, that's the example he gives. Now, when he's talking about privation, he makes clear what we mean by privation. You cannot have privation of something you wouldn't have by nature. Says it doesn't make sense to call this piece of chalk blind. Men are blind when they don't have sight, when by nature they ought to have sight. Furthermore, we don't say a fetus is blind, because they're not supposed to have sight yet. If a child is born and now naturally they should have sight and they don't, we now say that they're blind. So we only call them blind when they have a privation of something that they should possess by nature. Privation and possession. So blindness and sight, you cannot have a privation of something you wouldn't possess by nature. A fetus is not blind because it shouldn't see yet. A rock isn't blind by its very nature. And then finally, affirmation and negation, the most precise sense. A and not A. He's sitting and he is not sitting. In this case alone, it is necessary always for one to be true and the other to be false. Later we will say that these are contradictory. So the negation and affirmation, affirming something or negating it. One of those always has to be the case, and one of them has to always not be the case.
In this case, we often use the word opposite. It would be the most effective to use it in that context.
This is the one that's the most well-defined.
Yes.
This is the most precise notion, affirmation and negation.
Yeah.
Coming back up here, all swans are white. What's the negation of all swans are white?
There's a swan's white.
Some swans are not white. That would be its negation.
Yeah.
Not no swans are white. It would be some swans are not white.
Right. So the negation of red is basically anything that's not red.
Negation of red doesn't make sense. Negation applies to affirmations. Affirmations and negations.
Right. Well,
Asserting something is true or asserting something is false. They're opposite assertions. They're opposite booleans.
then my statement must be correct then, because if I say, is it not red?
Oh, sorry. I thought you said the negation of red. I heard you
No,
wrong.
that's
Sorry.
right. I did say that.
So red by itself does not have a negation.
Okay, hold
The
on.
negation of the chair is red is the chair is not red.
Yeah, that's what I meant.
Okay.
That makes more sense.
How did what I say the first not mean that?
I don't know. That's why I said I think the first time I misheard you.
Oh, okay.
Okay. So all swans are white. No swans are white. Those are not affirmation and negation. You could live in a universe where half your swans are white, half are black. Then are all swans white? No. Oh, so no swans are white? No. It's the case that some swans aren't white. Either all swans are white or some swans are not white. One of those has to be true, one of those has to be false.
I don't. The term contrary is still confusing to me like take for instance here, it says, no, while the contrary of a good is always bad, the contrary of a bad isn't necessarily good. In the sense of, let's say, the
These were not necessarily talking about affirmations. These were not necessarily talking about sentences.
they're not, right.
These are always, affirmation, negation are always talking about
True, false.
statements that you can call true or false.
Correct.
Okay.
So in contrary, oh man.
Contrary is more vague.
Yeah, I wish, could you define it again for me? I don't want to really get it.
We don't have a definition for what, we will define contrary statements, and that I will give you a definition for. Contrary statements are statements that cannot both be true.
Oh,
Contradictory statements are statements where one has to be true, one has to be false. Subcontrary statements are statements that can't both be false. One of them has to be true. Give you an example of some contrary statements. Some swans are white, some swans are not white. One of those statements has to be true. They can both be true, but one of them has to be true. Some swans are white, some swans are not white.
And that's called what now?
Subcontrary statements. So contrary statements, subcontrary statements, contradictory statements, that's different than what we're talking about here. Although this is talking about contradictory statements. Contrary here is more vague than that, because you can have contrary terms. What's contrary of bigger? Smaller. What's contrary of black? White. What's contrary of good? Bad. These are just things that are kind of understood by what we're saying.
So it's
How people are using the words.
right. I got it. So it's not rigorous at all.
Not rigorous at all. We are talking about the way people use language.
Then I'll let it go.
Of the way that people use opposites, here's the only one that's precise.
Okay.
Okay.
I really want to understand these, and I understand we've gone for a bit, but I really want to understand this privation and possession, and really what that means as far as opposites go.
Privation is not having something that you ought to possess by nature. Possession is having the thing, is what he means when people are talking about opposites.
So the opposite.
When they're talking about what's the opposite of being dumb, being able to talk. We would not say a rock is dumb. Although we use the expression dumb as a rock, I just realized. But in Aristotle's sense, we would not say that a rock is dumb. That's not what we mean. Because it shouldn't have been able to speak by nature. So when we say in a person, what's the opposite of them being dumb? Them being able to speak. What's the opposite of them being able to speak? Them being dumb.
So it's relative to the instance being expected to perform.
Yeah, so here we are talking about the opposites of properties that objects possess.
It's relative.
It's just one of the ways that we use the word opposite.
Okay.
No rigorous definition here, just analysis of how people are using language.
Yeah, that's good to know.
All right, and then prior, another one that comes up a bit. So what do we mean by this word prior? First off, there's prior in time, as in yesterday is prior to today. Pretty straightforward. Next one, prior in implication of existence. Not as straightforward. He says one is prior to two, since two is defined in terms of one. So if two exists, one must exist. The inverse is not true. In other words, if you have $2, you must have $1. Just because you have $1 does not mean you have $2. You must have the $1 before you can have the $2. It's in some sense prior to it. Prior in implication of existence. Now we get to the weirdest one. Prior in reciprocal implication. Okay. We're going to look at the fact of reality. Pretend I am Jack and I am exactly 6 feet tall. So we're looking at the fact of reality that Jack is actually 6 feet tall. And we're going to look at the statement, the sentence, these collection of words that assert Jack is 6 feet tall. With me so far? One, we're talking about the fact of reality. One, we're talking about the collection of words. Now, if this collection of words, Jack is 6 feet tall, is true, then the fact of reality, Jack is 6 feet tall, is true, right? If I tell you this statement, you make the statement, the words come out of your mouth, Jack is 6 feet tall. If I tell you that's true, then it must be true in reality that Jack actually is 6 feet tall. You with me?
The same thing.
But there's two different things. One's the thing you wrote on your paper, one's the fact. If you wrote on your paper Jack is 6 feet tall, and we went and we measured him and said, nope, he's 7 feet tall, you're wrong.
So it's like the result of my statement.
But if your statement is true, then the fact of reality must be true. You with me? And if the fact of reality is true, then your statement must be true.
Is that why it's called reciprocal?
So, yeah, they both imply each other.
Sounds like practically logically identical.
It sounds.
Almost.
sounds
Now
right.
here's what he says. But which one is prior? The statement is dependent upon the fact of reality. So Jack actually being 6 feet tall is prior to the statement, Jack is 6 feet tall, but they both imply each other. So this is prior to this, but there is a reciprocal implication. They both imply each other. Up here, 1 is prior to 2, but there is not this reciprocal implication. They do not imply each other.
Right.
That's very true.
Okay, 2 ways that we use the word prior. That's the hardest one to wrap your head around.
That makes sense.
Next one, prior in order. The example he gives is the introduction of a speech is prior to the conclusion. Now he means like a written down speech.
Yeah.
So not one that you're actually talking. He's not talking about prior in time. You could have read the end of the speech, then gone back and read the start of the speech. You could also think about this as the conclusion of a book versus the introduction to the book. The intro to a book comes before the conclusion. You can still read the conclusion before the introduction, but the introduction is prior to the conclusion. That's what he means. Prior in order. And then finally, prior in superiority. Those things people especially value and love have priority over others. And he says this is the least precise way that we mean it.
More qualitative.
More qualitative?
Qualitative measurement in degrees of a.
Oh, I see what you're saying. Sure. Yeah, your kids take priority over your job or whatever.
Just, yeah.
You're somehow saying one is prior to the other.
How would he be able to separate, for instance, prior in time and prior in order when they both are somewhat prior based off of?
You can think about prior time as a sequencing of events, and then think about them as both sequences.
They are both sequences, and I guess prior means that. I just don't know how you could describe one being so significant that you would take it and put it in its own
Because
way.
when people construct their arguments, these tricky sophists, they'll use the word prior one way, and then since you admit A is prior to B, then they'll say, and so A is prior to B, and mean it in a completely different sense, to get you to make a leap in logic. These are the sophistical tricks that they use. They keep using the same word, but in slightly different senses. And since you say that event A is prior to event B in time, you might end up saying A is in front of B in a line at a grocery store. Give you one really simple example of these sophistical, a story of these types of sophistical usage of words. A sophist is talking to a farmer, and the sophist notices that there's some puppies running around. He says, are those puppies the puppies of that dog? And the farmer says, yes, those puppies are the puppies of that dog. He says, you're sure that dog is the father of those puppies? He says, yes, I'm positive. I saw the father come together with the mother, and those are for sure the puppies, and this dog is their father. And so those puppies belong to you? Yes. And that dog is their father? Yes. So, since those puppies are yours, and that dog is their father, then that dog must be your father. And those puppies are your brothers and sisters. Because the dog is yours, and the dog is the father. So the dog's your father. And so the puppies must be your siblings. And so they would slowly, gradually, using words in one sense, twist it into another sense to try and bamboozle their opponent. And then their opponent realizes something went wrong, but I'm not sure where it went wrong.
So this is why what he was teaching was so vital for unraveling this deception and
Some of it is intentional deception, some of it is unintentional deception. Sometimes people are just confused by words. A common one at this time is infinity, indefinite, and boundless. Those are three concepts that they all have confused together at this time. Prior is one of these concepts that they have a bit confused at this time. Aristotle says we need to be very precise by exactly what we mean and specify what we're talking about. So again, remember the categories, it's just breaking down words and how people use words and making sure we use them right. All right, 2 more words, well, 1 more word and then change, and then we're done with categories. So another word he talks about is what does it mean for 2 things to be simultaneous? Those things are called simultaneous without qualification, and most strictly, which come into being at the same time. If you 2 light a match, and if that fire comes into being at the exact same time, we said those 2 events are simultaneous. They happen at the exact same time. Now notice that he has a Newtonian notion of time here, where time is this static thing we can somehow all agree upon. It's one of the big things Einstein had to do in his special relativity paper, is to get very careful about what exactly we mean by simultaneous. He's redoing what Aristotle did. What exactly do people mean by this word? But simultaneous, those things are called simultaneous, which, without qualification, and most strictly, which come into being at the same time. Good? One more thing he calls simultaneous. We also call codependent concepts simultaneous. Concepts where one doesn't really make sense without the other. The example he gives is half and double. Half and double come in at the same, both those concepts are related to each other in this sense. If I say, let's look at half of something, what's the half of this thing? It's what when you double, you get back what you started with. That's how you would have to say it, or something that's logically equivalent to that. Half is somehow what you have to double to get back where you started. Where double is somehow what you'd have to get back to where you started. So they're codependent concepts. They come into existence with each other. Another example would be the part and the whole. What does it mean to be a part of something? It means you're a piece of the whole.
So whole is created the minute you mention part of it.
They're simultaneous in that sense. You can't really give someone an understanding of what's meant by whole without also talking about a part. Right? It's all the parts. That's the whole thing. Same with half and double. So there's a less precise way. So the precise way is at the same instant of time, both those things come into existence. Not simultaneous. Less precise way. And then finally, change. Remember what kickstarts a bunch of this is change, conversation about change. What does Heraclitus say about change? And pretty much all the Greeks after him? All change implies a contradiction. You have what is not becoming what is, and what is becoming what is not. When you paint a chair red, you paint the green chair red, you have the green chair going out of existence and the red chair coming into existence. What didn't exist at the start? The red chair. What exists at the end? The red chair. So you have what is not becoming what is, and what is the green chair becoming what is not, going out of existence.
Simultaneous.
Well, you have this happening. The point is, here's how all change is talked about. Aristotle says this is ridiculous. We can talk about change more refined than that. He says there's actually 6 types of changes that we mean. So first off, there's the change of generation and destruction. This is the type of change being talked about, where the object either comes into existence or goes out of existence. When you have generation, you're creating a new, I erased it, secondary substance. When you have destruction, you got rid of that substance, that secondary substance. It's now a different form. Let me give you an example of generation. You have wood and nails, you don't have a chair. You then combine the wood and nails together to produce a chair. You just generated a chair. If you then carefully disassemble that chair back into the wood and nails, you no longer have a chair, you have wood and nails.
Does that still imply a contradiction?
Does that still imply a contradiction?
In the minds of Greeks, yeah.
So we'll have a lot to say about change before, when we get to the metaphysics. Aristotle says no, because you still have something that existence, the matter of the thing. You say, what's the matter of a chair? What is a chair composed of? It's composed of wood and nails. And when you have the chair together, you have the wood and nails. When you take the chair apart, you still have the wood and nails. Nothing new really went out, the matter that it's formed of, so he talks about form and matter. You change the form that matter was in, but the matter is still there. You had chairs and wood, you still have chairs and wood. Or sorry, you have wood and nails, you still have wood and nails.
So
Before and after.
Generation and destruction is still subjective we just assumed that the destruction of the wooden nails was not the chair. I don't know. It's hard to.
Generation and destruction is adding or removing form.
Is it combining?
It's
Adding.
you're taking matter, and if you give it a form, you're doing generation. If you remove the form, then you're taking it through destruction.
It's confusing.
Take it on an atomic scale. I can generate a sugar by putting carbon, hydrogen, and oxygen together. And I can destroy the sugar by breaking those chains again and breaking it back down into those component atoms. But the atoms were there in both when I had the sugar and when I didn't. I still had all those atoms. All those atoms were there the whole time. Nothing new really came into existence. Nothing new really went out of existence. I just took my matter and I put it in a particular form.
Yes.
So all we did was change the form of the matter. We didn't really get rid of any of the matter. And so in this deep sense, there is no such thing as really creating anything. Creation, as in something from nothing, doesn't happen. In any time that we create something, we create it out of some material. And that material is there even when we destroy it. We can create it out of that material and we can return it to that material. You can add the form, that's what we call generation. You can get rid of the form, that's what we call destruction. I can build the chair, and then I can take a sledgehammer to the chair and break it up into its individual pieces. The matter it was composed of is still there. We didn't get rid of the matter.
Okay.
So that's what he would say with generation and destruction. We will have a lot more to say about this when we get to metaphysics.
Right.
We'll focus on law on change and how things change and the 4 causes of change. All right, another way things change is increase. They get bigger. For example, you take a rabbit and you feed it a bunch of carrots. And the rabbit gets bigger and bigger and bigger and bigger and bigger. You didn't destroy the rabbit. You didn't generate something new. You didn't generate a bigger rabbit out of a smaller rabbit. There's no generation or destruction going on. All that's happening is it's increasing. It's getting bigger.
Would something like a caterpillar turning into a butterfly be that, or would it be generation?
I think he would put that here. But so you feed the rabbit, overfeed it, gets real fat, that's increase. Diminution, that's getting smaller. You start starving your rabbit, it starts decreasing in size. Alteration, you might decide you don't want a white rabbit, you want a black rabbit, so you paint the rabbit. It's still a rabbit, you didn't destroy it. You didn't generate something new, you didn't destroy anything, you just painted the rabbit. Similarly with your chair. You can paint the chair, it's still a chair.
So the essence of the thing is still there?
The essence of what it is still there.
Just rearrange the substance.
Well, you altered it in some way.
Yes.
Give you another example. You might have a nice little kid, and I teach him how to distill. I altered him in some sense. He's been altered. He's still the same kid, but now there's an alteration that just happened. So, don't want to get too tied to physical things, but yes. And then finally, change of place. I'm here, now I'm here. Change of place, change of location. Why not change in time? I'm here, now I'm here.
Oh yeah, why don't we have that? Oh wait, because you can't change.
Time is a necessary condition for change, right? We change in time.
That makes sense.
So we don't count as me being here, now here as a change.
Yeah, right.
If the only way I'm changing is in time, then we say no change has happened.
Does Aristotle consider change of place to be a relative thing?
So location is relative, but it's not a relative term, meaning a relation. Because location tells you where you are relative to your surroundings. So when he said relation, he meant something like the word double, which now I have to give 2 terms to make it make sense. When he talked about location, he meant in the Lyceum. So it already encoded one of the things you're relating to, and you just need to give what's in the Lyceum. So it's relative, but it's not a relation. And unfortunately, he chose the word relative for relation, which, well, I shouldn't say he did that, the translator did. They should have used the word relation, it's a better word.
So when he's saying change of place, it's the object relative to the place is changing.
Right. Relative to its surrounding, it's not in the same location as it was. But yes, your position is relative. He wasn't thinking as carefully about that as Galileo was.
So he's not trying to define location in any kind of objective indefinite way.
No. It's just so far getting at how we use words. When we get all the way to it, he would say that there is absolute space that we can start measuring from when we get to his physics, because he thought that the Earth was at the center of the universe. And so he thinks that it does make sense to talk about the center of the universe, and that would make sense. But that's getting to his physics. So 6 times it changes. We talked about alteration. Oh, we talked about all. Okay, so those are the 6 ways that we can change an object. So all you ancient Greeks, stop pretending that these are the only 2 ways, because they're not. We have these other things where there is no generation or destruction. That's one type of change, or those are 2 types of changes, but there are these other ways. Okay, any questions there? All right, just give you a sense of this. This now concludes the categories, which is the first portion of the Organon. So far, we have covered 25 pages of Aristotle in everything that we've covered of his in the Organon.
Well, very important.
The point is, it gives you a sense of how dense this guy is if you go and try reading these things yourself.
How many pages is there now?
Aristotle or in the Organon?
I guess both. I don't know. Organon again? Organon is the category section.
So the Organon is composed of 6 books.
Okay.
Categories, where we talk about words, meaning of words, simple concepts. On interpretation, where we start talking about sentences.
Oh, that's right.
Prior analytics, where we start talking about how we combine sentences together in arguments. Posterior analytics, where he lays down the foundations of science. Topics, where we talk about deliberation and the different starting points of deliberation. And then finally, sophistical refutations, where he trains you how to argue.
Right.
Cool.
We're not going to cover those last 2.
Uh,
It's very targeted at how arguments are going in his day. So he's looking at dialectic, where you take turns asking the questions and answering the questions. And so he's kind of like giving you tactics. When you're the questioner, da 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 da. When you're the one answering the question, da 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 da.
It'd be nice to know.
It's interesting stuff. It's just of his works, it's far and away the least important in the book.
It does sound like that was a huge amount of his motivation was to get things straight in these arguments and conversations.
And it was also a very practical thing for him to do in his day, dealing with these people and teaching his students how to deal with these people.
Yeah. I mean, well, I deal with that. All of us deal with that on a daily basis.
Well, but I mean, our lives aren't, it's not accepted that we use the dialectic to come to knowledge. We now have this notion of the scientific process. His whole science is now caught on. And so he doesn't have to focus on this other way of dealing with things. We now all use science in our arguments for the most part.
And logic.
Yeah, his logic caught on, his science caught on, and so
It's been more effective than
he's very happy with where things are now.
Yes. Oh, so I was just curious, what's the general amount of pages are we talking in the Organon?
In the Organon, I can't remember the book I'm using. I think it has roughly, I want to say 500-ish. I could be wrong.
Pages?
How many total of Aristotle's words? Because they were lecture notes, right? How many notes?
They were lecture notes. If you got the complete works of Aristotle, I think it would be a 3,000 to 4,000 page book.
Whoa. That's a lot.
What?
Not positive.
Actually, the Organon and the Great Book series is split up into 2 different volumes.
Oh, he's probably going to cover the Organon in both those. He's covering Organon, metaphysics.
I mean, yeah, everything you just said. Yes, how many pages? It's
Oh.
in the Great Book series.
So in the
it's
Great
2
Book
volumes.
series, it's 2 volumes, and that's him picking stuff out. He's not giving you Aristotle. He's picking things out of Aristotle to give you.
Wow.
And it's 2-volume work. So in terms of his lecture notes, I once looked at the words, and it came out to roughly the first 5 Harry Potter books in terms of word count. So there's a lot. Obviously, we can only cover a small portion of it, but we'll try to pick out the important things. All right, so his next work now on interpretation. So we're done talking about simple words, simple notions, and we're going to basically start talking about now about sentences. So this is kind of talking about logic, but also kind of talking about grammar. This is something that is so sad that it's lost nowadays, is we teach grammar, but we don't teach logic. If you were to ask me, what's the closest course there is to logic, the closest thing is grammar. If you were to ask a modern high school student, they say, logic, isn't that part of geometry? That's what logic is. No clue. And so we're going to see the terms that we use in grammar and the terms that we use in logic go hand in hand with each other, and there's a reason for that.
And that makes sense, actually.
It makes perfect sense. When you diagram a sentence, the first thing you do is you split it up into its subject and its predicate. Someone in a logic course might say, you mean the predicate and the term? Yes, that's exactly what we mean.
Wow.
So that's what it is. When we went back to classical education, when you got your liberal education, what were the 7 fields? First, logic and grammar. Those were the first 2 you did. Then you would do arithmetic. We now call that algebra. Then you would do geometry, which we call geometry. Then you would do astronomy, but astronomy as a medium for studying motion. A better name for that now would be classical mechanics. And then you would study music. Music as in studying motion that creates sound, not learning to play an instrument. We would now call that wave mechanics. And then finally, rhetoric, how to speak persuasively. That was your liberal education, the education worthy of a free man.
That's very useful.
If you're going to be a free man in your society, you better know these 7 things. And now, we've completely gotten rid of logic, and there is a huge effort in academia to push geometry out.
Have you been able to teach?
Huge
logic
effort in
and
education. I've taught it here
Have you
and
requested?
had people come.
Yeah, have you requested and they turned it down or what?
It's just such a setback. I mean, you got to pick out of all the things I'm going to teach, what should I teach now? So I do logic as a crash course at the start of anything I teach, pretty much. And if you've taken classes from me, most people who've taken classes from me aren't here. They're annoyed because every class I start with, let's do a crash course on logic. And even in this class, I started it with, let's do a crash course on logic.
I love it.
And that crash course on logic, by the way, you're going to want to go back and watch for next week's lecture. Thought we might get to a bit of it today. We'll see. Okay, anyway, so on interpretation now, getting to sentences. So, language symbolizes mental experiences. You have some mental experience and you use language to codify that mental experience. And the written word symbolizes language. Make sense so far? While people write and speak differently, we all have the same mental experiences. We say cat, the French say chat, I'm not sure how they pronounce it, but it symbolizes the same mental experience. It's why we're able to communicate. It doesn't matter what language you speak, what language you write, we're all ultimately able to communicate with each other because we all have the same mental experiences. And all communication is ultimately about those mental experiences. Make sense what he's talking about so far? Okay. So now, when he is diagramming his sentence, he's splitting it up into a noun and a verb. By noun, he means the subject. By verb, he means the predicate. Now, why did he say subject and predicate? Because the noun are the words that represent the subject. There's you, the subject, as a thing right here in the universe. And then there's the noun parly, which represents you. It signifies you. A noun is a word. You are not a word. You are a subject. So you're the subject. The noun, what's a noun? Is something that signifies the subject. By convention, a name. What name we choose is completely arbitrary. That's what he means by convention. So the fact that we choose to signify you with the collection of letters parly is completely by convention. That doesn't matter. It's somewhat arbitrary. The fact that we chose chair to signify that thing completely arbitrary, that's a convention. Who cares? But the thing that it's signifying is the thing that it's signifying. So, the noun are just the words, the subject is the thing. So, noun signifies the subject by convention, a name, but without reference to time. Now, without reference to time might sound kind of weird, but we don't put, when you talk about a particular subject, there's no reference to time to it. That'll make sense as we give an example. Notice that health, when we talk about health as a subject, that has no time implication on it. But if I say, on the other hand, you were healthy, or he was healthy, When I'm now predicating it of you, it now introduces a time component. The time exists in what we predicate of something, not in the thing itself. Okay, so now the verb. The verb is a sign, or the verb signifies. The verb is a sign of something said or predicated of a subject. That's what he means by verb here. So the same way that we say subject and predicate, he's using noun and verb. He's not going to talk about the 8 parts of language that we use today. For him, there's just 2 parts of language. He's the first one to do grammar. He's the first one to break up sentences like this. All right. So it's a sign of something said or predicated of a subject. It carries with it a notion of time, typically in the tense of the verb, with an untense verb indicating the present. So when I say Parley is healthy, when I predicate healthy of Parley, and I don't put any tense on it, it's understood it's the present. When I say Parley is healthy, what do I mean? I mean Parley is healthy right now. And you can't use the fact that Parley is healthy later to say, oh, you contradicted yourself. No, it was understood that when I said Parley is healthy, I was talking about it in the present. So, nouns are the same way that we use subject today. Verb are the same way that we use predicate today when you diagram a sentence. That's what he means here. He's separating it. Subject is a physical thing. Predicate is what you're actually predicating of it. Nouns and verbs, those are words on paper that exist in sentences. Make sense? That's the distinction. Now, while nouns and verbs are significant, they signify something, they do not by themselves signify a fact or a judgment. They do not signify something that we can call true or false. It's only when you combine nouns with verbs that you get what we now call declarative sentences. First thing you learn about every declarative sentence has to have a noun and a verb. It's going all the way back to Aristotle. Every declarative sentence, everything that you can call true or false, has to have a noun or a verb.
What did he think of about other parts of language besides just nouns and verbs?
So you're talking about like adjectives, articles, conjunctions?
Yeah.
So for him, he's not breaking it down that fine-tuned. So now when we diagram a sentence, we break it down into its 8 different categories that way. He kind of thought about them as representing, remember, he's thinking about simple concepts rather than individual words. And he's already categorized his simple concepts. He's focusing on the concept you're symbolizing with the words rather than the words themselves. So right now, early on, there is this mixture between logic, grammar, and basic facts of the universe. And those 3 are all kind of muddled in his mind. It takes time to separate those 2 out. So for him, the parts of a sentence are just the noun and the verb. And these are whole collections of words, not necessarily a single word. And he would have, I don't know when the 8 parts of language came into existence. All right. I think we saw that. Any questions on the slide so far? Okay. So a sentence, it's a significant portion of speech. It must signify something. Some parts of which have independent meaning, meaning the noun and the verb, whose meaning is established by convention. In other words, the nouns and verbs that we use are completely arbitrary. Remember, he thinks that a chair has an essence. That's not a matter of your opinion. That's a nature. The name we use is a convention. Convention and nature go hand in hand for the Greeks. Either something exists by convention or something exists by nature. So those mental experiences we have are experiencing the nature of a thing. The words and language that we use to describe it, that's completely conventional. And that's somewhat arbitrary. But since we're talking about the same nature, communication can happen. Because what we're talking about exists by nature in nature. And that's what we mean by nature. Things that aren't conventional. And we have that whole notion now of the natural sciences. These are things that go beyond convention. We're not talking about wordplay over here. We're talking about things that are independent of you, me, anyone else. So, I don't know if I'm overstressing that. Anytime you see the word convention, always think as opposed to by nature. Okay, so proposition. A proposition is something that is either true or false, not both. So it's either true and not false, or it's false and not true. No concept of it possibly being both true and false. While not all sentences encode propositions, there's such thing as declarative sentences, interrogative sentences, imperative sentences, exclamatory sentences, whatever. While not all sentences encode propositions, sentences are capable of expressing propositions. Example, John is 18 years old. That is expressing a proposition. Now, we're going to start getting lazy and we're going to start calling this a proposition. But it is very important to understand the difference between this sentence and a proposition. The proposition is John is 18 years old. If I were to rewrite that in French, it would be the same proposition, but different language, a different sentence.
Right.
So there's a difference between the sentences and the proposition. We use sentences to encode propositions. Does that make sense? Okay. But we'll kind of be lazy in our language now and start calling that a proposition and have understood what we're talking about. Simple propositions convey a single fact. Every simple proposition contains a verb and a noun. Aristotle is mortal. Simple proposition. This table is white. Simple proposition. Aristotle is mortal and this table is white. Non-simple proposition. So simple propositions convey a single fact. Every simple proposition contains a verb and a noun, exactly as you were taught in school. Every declarative sentence has a verb and a noun, saying the same thing. And compound propositions are composed of multiple simple propositions, put together with some sort of conjunction. Good? All right. The subject of a proposition can either be universal or particular. Let me give you an example. Men are mortal. That is a universal proposition. Men play football. That's a universal proposition. Socrates is mortal. That's a particular proposition. Now notice that with universal propositions, they introduce some ambiguity. Question: is it true that men play football? Yeah. Is it true that men are mortal? Yeah. What do we mean when we say men are mortal?
Every man.
We're saying every single man is mortal. What do we mean when we say men play football?
Some men.
We only mean some men play football.
True.
So we're using men in this univocal way. It's not very clear exactly what we're talking about. So when you have a universal subject, just to be super clear, I think you all got it, but just to be super clear, when we look at this men are mortal, we are predicating mortality of men. Men is our subject. And we're predicating mortality of them. Men are mortal. Similarly, when we say men play football, we're predicating plays football of men. Similarly, when we say Socrates is mortal, we're predicating mortality of Socrates. I just want to make it very clear, this is our subject in each one of these. So universal subject, particular subject. That's one thing. That's many things.
Yes, the category.
Okay, just want to be super clear. Okay, so when a proposition is universal, not proposition, sorry, subject. When a subject is universal, it can have a quantifier, either a universal quantifier or an existential quantifier. Which is why I asked you what these mean and you add the quantifier. When I say men are mortal, what's that saying? You said all men are mortal. You add that universal quantifier, all. When I said what does this mean, when you said men play football, you said some men play football. That's the existential quantifier that you just added to it. So you can add these quantifiers to your universal subjects to make it clear what they're saying. So men are mortal, it's not clear what you're saying. If you say all men are mortal, now it's clear. If you say some men are mortal, now it's clear. If you just say men are mortal, it's not clear what you're saying.
Is it going to be both?
Yeah, we're not sure what it is. It's ambiguous. So you need to add your quantifiers. If you're going to have a universal subject, you have to add a quantifier in order for it to be clear what it is you're saying. So when a subject is universal, it can have a quantifier, either a universal quantifier or an existential quantifier. Thus we can say all men are mortal or some men are mortal. We must be saying one of those two things. Make it clear what you're saying. If it lacks a quantifier, Aristotle called those propositions indefinite. And in short, we can't do logic with indefinite quantifiers. You need to make it clear what we're talking about. It needs to be definite what we're talking about. But, thus we can have universal, particular, and indefinite propositions. So, notice what we've done so far. We've looked at sentences, and we've said we only care about sentences that are true or false, propositions. Now we're going to look at propositions, and we're going to whittle it down to the ones we care about. So we have three types of propositions so far. We can have universal propositions, particular propositions, or indefinite propositions. Example, all men are mortal. We're going to call that a universal proposition. Some men are mortal. We're going to call that a particular proposition. Plato is mortal. Again, that's a particular proposition. And then men are mortal. We're going to call that an indefinite proposition. Good so far? Now notice that some men are mortal and Plato is mortal are both particular propositions.
Okay, all men are mortal is not a particular proposition. Some men are mortal is a particular definition.
Proposition.
Proposition.
Plato is mortal is a particular proposition.
Because we're talking about, so a particular proposition can include multiple particulars.
Yes, it's saying there is at least one thing with this property.
So some men are mortal is a particular proposition.
How-
Yes.
But some men are mortal can mean all men are mortal.
All,
No. Some men are mortal allows for all men to be mortal. The same way that Plato is mortal allows for all men to be mortal.
Yeah.
It does not state all men are mortal. It allows for that to be the case. So I think I can help this make sense for you. I'm going to rewrite this using our notation. So our two quantifiers, hopefully these symbols, I told you they can't scare you. That is our universal quantifier for all, for each, for every. And then our existential quantifier means some or there exists. So, some men are mortal. What does that mean if we write that out explicitly? It means that there exists something, there exists X, such that mortality applies to X, and man applies to X, and is going to die applies to X. That's what it means when we say some men are mortal.
Yes, right.
Okay. Similarly, when we say Plato is mortal, what are we saying? We're saying that there exists some X out there, such that Plato applies to that X, and is going to die applies to that X.
Yep.
That's making explicit what it is we're saying when we say Plato is mortal. We're telling you two things. We're telling you that there's something in existence that is a Plato, whatever that means. And we're telling you that that same thing in existence is mortal, is going to die. And that's exactly what it means. So Aristotle, he's going to try and reduce all our different types of propositions to some basic ones that we can encode everything in. Now, he didn't have notation near this granular, but it's just much easier to use this notation than to try and keep track of everything he's going to talk about. Because he's going to break it down to ultimately, like, I don't know what it comes down to, 128 different cases. It's much easier for us to just get the symbols and use the symbols to reason about them. All right, so, note, we are typically interested in universal and particular propositions composed of universal subjects and quantifiers. In other words, we like statements of the form, for all X, some predicate about X, and that predicate could be some conjunction that implies two things about, that's fine. But for all X, something's true about X, and there exists an X such that something's true about X. And these are the two ways that Aristotle is going to write out all his propositions. He's going to say for all X, this is true about X, or there exists an X such that this is true about X. And he's reducing all propositions to these two standard forms. Well, he's going to do these and then two versions of them. Put a negation in front of that and a negation in front of that. And those four forms, those are going to be called almost his four categorical sentences or statements. We'll make more sense of that, but that's what he's trying to do here. It's trying to come up with some common structure that all propositions have, or could conceivably have. We can rework them to have that structure. And then once we have that common structure, we can start looking at ways to combine them together. That's what he's after here. We're not going to be able to finish this, so let me just jump the gun for you where we're going with all this. Because here's what Aristotle is fascinated by. Let's look at a typical proof that we all accept. So we all kind of accept that Socrates is a man. I can close this now. Socrates is a man. Men are mortal. And then those two facts together imply what?
Socrates is mortal.
Yeah. Socrates is mortal. Now, for some reason, if these two are true, then this is true. If, on the other hand, I said something like, Socrates is an animal, all pigs are animals, therefore Socrates is a pig, that logic doesn't work.
Right.
Now, notice that this statement does not depend on you knowing Socrates, mortality, or men in order for it to be true.
Yeah.
I could get rid of all the men here and replace it with an A. I can say Socrates is an A. All A's are mortal. Therefore, Socrates is mortal, and it still works. Furthermore, I could have gotten rid of mortal with a B. And if I know Socrates is an A, and all A's are B's, then Socrates must be a B. And we can get rid of Socrates. And I can say that as a C. If I know C is an A, and all A's are B's, then C is a B. And it doesn't matter what the A, B's, and C's are. This form somehow always works. And he's going to call this right here the minor term. He's going to call this right here the major term. And he's going to call the A here the middle term. And it seems like if you get two sentences with the right structure and the middle term related the right way, you can kind of hook them together. And it enables you to say C is somehow now related to B. And certain structures seem to work, and certain structures don't. For example, if I know that all A are B, and I know that C are B, I cannot then conclude A are B. That one doesn't work. There's something wrong with that structure. There's something right with that structure.
Well, it's a mathematical definition or whatever it's called, where if C is equal to A and A is equal to B, then C is equal to B.
That's a transitive property, but...
Isn't it kind of...
Wait, you're saying...
No, we typically now think about this as subsets. So we think if C is a subset of A, and A is a subset of B, then C is a subset of B. That's one standard way that we think about it. Go ahead.
Did you mean to say A or C when you were doing that one? Because you said A or B. A or B.
Thank you. Yes. That was supposed to be my middle term. So when you have the middle term on the same side like that in the universal forms, it doesn't work. But when you cross it, it works. And so he's coming up with the structures of argument. He said, let's ignore the particular things that they're talking about. Let's ignore the matter of the argument, the things that the argument's formed of, and let's look at the form of the argument. He's looking in terms of matter and form. He says we're just going to look at an armed form. We're going to look at its structure, the form of the argument. And that's why we call it formal logic. It's just looking at the form that the argument takes. It's ignoring the argument's matter. It's not talking about the particular propositions. It's talking about the form that those propositions have.
Kind of like an algebraic approach to mathematics.
Well, it turns out it's more fundamental than algebra. It's logic. You use logic to develop algebra.
Yeah, but it's like formulas.
Huh?
They're like formulas.
They're like valid ways of reasoning. We use valid ways of reasoning to develop our formulas.
Yeah.
It's more foundational than that.
Okay.
Fair.
Like, to remind you of the structure, it's drawing our pyramid here. Here we have logic. And then on top of logic, we have math. And on top of that, we have physics. And on top of that, we can have chemistry. And on top of that, we can have biology. And it's always valid in biology to use chemistry. The converse is not true. It's always valid in math to use logic. The converse is not true. You cannot use math to give logical arguments.
Right.
Because whatever that math is, you ultimately have to use logic to establish in the first place. You end up using circular reasoning in some way.
Yeah.
So logic, this is the rules of argument. And now we can argue why our formulas hold
Gotcha.
using logic.
Right.
And the laws of logic, remember, those are metaphysical laws. Those are laws of existence. Everything is subject to them, both physical and non-physical. This physical piece of chalk is subject to it, but so is Newton's law of gravity. Newton's law of gravity cannot entail a contradiction. It's impossible. It violates a metaphysical law.
Right.
So your metaphysical laws apply even down here. That's the first place that they apply, and so our laws of logic can be used. Well, there's two ways to say it. Since we're just looking at what our laws of logic give us here, we can use it everywhere because metaphysical laws apply to everything, is how Aristotle might say it. Anyway, so that's where we're going with this. So we're going to get sentences into their common forms and then look at certain ways we can combine them together, and it works. And other ways we try and combine them together, it doesn't work. There's just some valid forms and some invalid forms. And we'll get going with formal logic. Any questions you want recorded? Okay, remember, first lecture, I did a crash course on logic. If any of the logical symbols scare you at all, let me just write them out really quick so you know what all the symbols are. For all,
There exists.
just going to do it backwards. There exists not, and, or, implies, equivalence, and then finally, giving you an example of combining them all together. This says, for all x, if P applies to x, then Q applies to x. This is how you would read that. So if any of that scares you, in particular for people on the camera who weren't here, first lecture in the playlist, we did a crash course on logic where we explained all the symbols, what they mean. Strongly recommend it before next class because we're going to be deep diving into Aristotle and we have much better notation.
Do you also use contradiction to the symbol for that?
No, we don't use any unary operators because you can express with binary operators. I guess not is the only unary one we use. And also, he goes over modal logic, but we won't be doing anything with modal logic except mentioning it. But if you want to see an example using modal logic, you can go watch my proof, my going over Gödel's proof for the existence of God, which is the last episode in the playlist that uses modal logic. Modal logic uses this and then some more. It introduces the possible operator, which is a diamond, and then the necessary operator, which is a square. Anyway, that's all it extends on. Okay, any other questions? We good for next week? All right.
Thank
Very
you.
welcome.